Good morning. Welcome to the Minoxidant webinar series. My name is Emily Adams. I am the Business Development Manager at Minoxidant. Today's presentation will focus on underground FRP installation made easy, facts and fiction. Today's presenter is Jim Wishusen. Jim is the FRP Division Manager at Minoxidant and has been with the company since 2010. A bit of housekeeping for today's webinar. In the lower left corner of your screen, we are encouraging participants to text questions to us. We will read back the questions and answers throughout the presentation in an effort to encourage dialogue throughout. Without further ado, we will turn over the presentation to Jim.
Thank you, Emily, and good morning to you all. I sincerely appreciate you taking the time to spend with us this morning. My name is Jim Wishusen, and part of my job description as FRP Division Manager is I do get to travel around and visit with all of our authorized reps, and in turn then go visit with not only their engineers that they call on, but also their contractors, and that sort of thing. And it's a very common question that I get all over is how do I install or how do I figure labor on installing FRP? The first thing that we do need to talk about is, well, why is more and more duct going in the ground in the first place? Okay, if this were just a splash in the pan thing, then it really wouldn't be a consideration. But there are a couple of driving factors that are forcing more and more duct in the ground. So the first and biggest driving factor is displacement ventilation. A lot of our representatives are, they do represent various displacement ventilation products such as grills, that sort of thing. And the difference being that in displacement, your ductwork is at a low elevation. And what better place to put supply ductwork at a low elevation than in the ground? Now, there's been a couple of things that have been done. ASHRAE took a look at this in a hospital setting, and they did some testing, and they realized that with displacement, 4 air changes per hour produce the same ventilation as 6 air changes per hour. So that's encouraging, and that the displacement setup, the stratification of temperature, while it was disrupted from time to time, it generally goes back within 30 seconds. So ASHRAE is encouraging displacement ventilation design. The EPA is also encouraging displacement ventilation, certainly for the energy savings in cooling mode, but also because it's a passive way of cutting down on transference of pathogens amongst humans. All of the nasties get pushed to the ceiling. Examples of where you would use displacement: basically, bigger is better. The bigger the room, the more energy savings you're going to get, the more you're going to reap the benefits. The picture you're looking at here is a Whitefish Bay terminal in Sydney, Australia. It's a huge building, public shipyard or ship terminal, and every bit of supply duct is in the ground that we did there. So all of the examples you see on the left clearly have opportunities for displacement ventilation. Okay, now in a commercial setting, what you're looking at here, functional, but obviously not the best aesthetic look. Your supply duct at the outside is brought down to the ground. Your return duct is up high. So that works, but in a architectural point of view, it's not as appealing as what you're looking at here, whether it be the auditorium approach with the round displacement grills, the floor grills, library setting, that sort of thing. The architectural community, but also by the end user. So by default, these applications would require duct in the ground. The other driving factor behind putting ductwork in the ground is, unfortunately, smoke control duct. There are many projects, usually on the larger end of scale, that are putting duct specifically devoted for smoke control in the event of a calamity. For example, we did a few of them, one of them being the Spears School of Business at Oklahoma State University. You're looking at 60-inch, 5-foot diameter smoke control duct being put in the ground okay? And its purpose is to function as exhaust in a calamity. So those are the two driving factors that are pushing more and more duct in the ground. So we've all looked at the ceiling, and it's not impossible. It's a mess, but it can be handled at some point. It's no different than installing utilities in the ceiling. The only difference is the ground itself. Okay, the ground can be wet, the ground can be corrosive, uh, and certainly, obviously, it's no different than installing things overhead. So if you take a look at other materials, all right, if you're going to put metal duct in the ground, whether it be galvanized, aluminum, stainless, it's going to go in just like it does above ground, except that you're going to have to encase it in concrete and more concrete. And the end result is with metallic duct that you're encased in concrete. Basically, in a short period of time, you're going to have concrete duct with rotting metal inside of it. So obviously, that is not a preferable material choice. When you go to the other option where you are raising a floor, you're basically building a bigger building. And in this cost-saving world that we live in, this is not the best approach. So a roundabout way of saying this is that there is more and more duct going in the ground these days, and the FRP underduct product by Minoxidant is a perfect solution for this application. It is an ICC approved product for direct burial. There's no concrete encasement required, and it has been thoroughly tested for low smoke, low flame, structural, leakage, insulation, you name it, it's been tested and it is approved. We like to tell contractors that yes, it is easy to use. It certainly is resistant to corrosion, and it is watertight. It's extremely efficient with its smooth inner liner, and it can be sent out to the job with factory assembly, which cuts down on your installation labor. When you are installing it, you're basically trenching out a trench that's approximately 1.5 times the width of the diameter of the duct. And you're going to line the bottom of that pit with either pea gravel or sand, and approximately 4 inches or so. And you're going to slope it back to the larger diameter or the start of the system, approximately 1/8 per foot. And that's to handle water if and when it gets down into this ductwork. Let's say a sprinkler pops, it's all going to collect down at the large end where you can easily remove it. The duct itself is approved for 6 foot underwater table, so it's not an issue for the duct. It's just you want to manage that water. Then once it's joined, then you pressure test it and backfill with sand or pea gravel. You can get it as close as 4 inches to under the slab, or you can get it deep as you want. So there's no issues with that. So it's a simple product to install in the ground. So if that is the solution, what's the problem? Well, let's take a look at it. And here's what we got going. So it's not putting the duct in the ground. Honestly, that's no different than doing plumbing or electrical banks or any other utility that you're going to bury in the ground. And the video you're about to see demonstrates a very simple installation for some underground vehicle exhaust duct. It demonstrates how it's trenched, how it's graded, and we'll just take a quick look at that. In this video, you're watching the time-lapse recording of some actual underground FRP duct being installed for a vehicle exhaust installation. Clearly, there's nothing frightening or different about the trenching that you see going on. It's a simple process that's done with many materials, drainage, plumbing, electrical banks, and so on. And it is the same simple process with underground FRP duct. So this isn't the cause of any angst or worry. Once the trench is done, it is graded using pea gravel or sand. I believe he's using pea gravel there, and he's using an 8-foot level to grade it 1/8 per foot, sloping towards the large diameter end of the duct. And once the trench is thoroughly graded, Then the FRP duct is laid out and installation begins. That part of the installation is no different than any other utility. It's a very simple thing to estimate how long it's going to take to trench it, grade it, and put the duct in the ground. But these are some lines that you're looking at right now, or direct quotes that I get from contractors all the time. I've never done that. And it's not what we normally do. I don't know where to start. And the biggest thing is I don't know how to figure the labor. Okay, well, let's take a look at the joining, because that is really where the question lies, is how to join it. That's where the unknown is. So when we send out all of the materials needed to join, we're sending out everything, the resin, the catalyst, and this is with the wet layup method, which has been around for 70 plus years. We're going to send out all of the glass matting. We're going to send out all of the simple tools, the buckets, the chip brushes, the hard rollers. The only thing the contractor is going to supply is acetone for cleaning and some personal protection for latex gloves. There's a quick video we're going to show you right now on performing this, and this video is available on the web for all to take a look at as well. So let's go on to that real quick.
The preferred method for making field joints for both Minoxavent's underduct and corrosion duct is the ASTM D3982 butt and wrap method. Our intention is to pass along field setup and working procedures that will supplement our written instructions supplied with the joint materials. Let's first review the field joint materials provided. There is an envelope containing written field joint instructions and material safety data sheets for resin and catalyst. Please review the MSDS sheets, paying particular attention to skin and eye exposure. The instructions will tell you how many layers of glass mat are required for each size joint. You will receive rolls of glass mat, resin, MEK catalyst, a hard roller, and a starter supply of buckets and brushes. You will need to provide acetone for cleaning tools and hands, as well as any additional brushes, buckets, and latex gloves. Store resin and catalyst in an approved job site location, avoiding extreme heat and cold. Glass materials should always be kept dry. Lay out your duct system, making sure to support the joints in order to restrict movement. Grind the duct outer surface approximately 4 inches on each side of the joint. If necessary, secure joints with temporary metal clips to prevent movement. Cut the glass mat strips in 18 to 24-inch laminating lengths. Also cut 6-inch long strips for hot patches. Review the written instructions for the number of layers for each size joint. Add 1 to 2% catalyst to approximately 1 quart of resin. At 70 degrees, you will have approximately 10 minutes of work time before the mixture begins to gel. Cooler temperatures will require closer to 2% catalyst, while warmer temperatures will require less catalyst. Saturate 1 strip at a time on a pre-cut piece of cardboard, staggering the strips side to side and end to end until you have the recommended number of layers. Lift the completed weld strip or hot patch and apply to the pre-ground joint area. Using the hard roller, roll out all the air from the wet laminate. After the hot patches have cured, remove the metal clips and finish the joint lamination. Thoroughly inspect all joints after they have been completed, grinding back and patching any air pockets or delaminations. For all above ground applications requiring a gel coat finish, be sure to grind any rough or sharp spots before applying the gel coat. Remember, proper field setup can save hours of installation time. Always be aware of the weather and never work in wet conditions. If temperatures are below 60 degrees, you will have to heat the joint area in order to start the curing process. At the end of the work session, you should always remember to clean your tools, store glass materials in a dry place, store resin and catalyst in an approved storage area, and always dispose of used materials in environmentally correct ways. For more information, please contact us at underduct.com or call us at 309 794 1000.
The video that you just saw there is available on our website, and some contractors will take a look at that and they'll say, okay, yeah, it's not that difficult, it's fine, I can figure it from there. Others, well, that's it's funny, but they're horrified by it. Well, the reality is that it's actually quite a very simple process. All right, there are some uh,
Hey, Jim, we've got a
tricks.
question for you.
Sure.
Steve Shelley would like to know, is this joint connected in the trench?
That's a great question, Steve. And for the most part, yes, it is. Uh, we do recommend you getting as much duct ready to go before you join it, which we'll get into shortly. But the duct, for the most part, is joined in the trench using the wet layup method. Okay, and the tool or the trick that helps you out, and you'll see that shortly, is the cardboard that you are wetting out your strips on. Okay, so to answer your question, yes, it is connected in the trench. So uh, we need to take a step aside and talk about other materials first. And the reason for that is that when you do use other materials, you are going to have all loose parts and pieces, straight lengths, reducers, fittings, taps, and you're going to bring it all to the job. And you're going to measure, and you're going to cut, and you're going to fit, and you're going to screw or glue or weld every single piece. Okay, that's just the nature of the beast. Now, FRP can certainly be do that way, but we do like to do factory manifolding. But when you are using these other materials, it's a mindset that says I connect it however I do it, and then I finish that joint in its entirety. So in other words, and this goes back to your question, Steve, I'm going to put a piece of duct in the trench, and I'm going to connect it to the next piece of duct, and I'm going to finish that in the trench right then and there, and that's with other materials. Um, and that's the way most contractors are used to installing duct, whether it be in the ground or overhead. Now, when you go to FRP, it's a completely different mindset, all right? Um, you are putting as much prepared duct in the ground as possible so that you have the most amount of field joints ready to go. Um, and you are basically doing all of your joints at the same time. And what that means that you've done a partial of the top of one joint, and then you've gone on to the bottom of the next one, and it's a process where you are literally doing everything all at once, and the efficiency of it is based on a system. As you see here, this gentleman is just roughing in FRP registered boots along with the taps. Uh, they're slightly connected, as you saw in the video, by a metal clip. And same thing that you got going on here. If you zoom in, you see these metal clips here. Okay, and that's temporarily joining it. And the concept here is to get as many joint areas ready to go so that when you start to mix your resin, you're doing them all at once. It's not finish one in its entirety and then go on to the next. It's you are following uh, the process of catalyzing resin, wetting out glass, and trying to end up with no extra resin. So that's the different in mindset, and that's what people have difficulty in quoting the labor on. The other part of doing this, as I said earlier, is a system. You do want to have a workstation. Now, in contradiction to the video that you saw, it talked about weather conditions less than 50 degrees or 60 degrees Fahrenheit. This picture you're looking at right here, this was taken by me pretty close to the Arctic Circle this May. It was pretty cold out, and these gentlemen were tasked with joining FRP. So obviously there was heat put into this little shelter, that sort of thing. But the key thing was the centralized workstation. All right, same thing here. yours truly here had the contractor set up this workstation, and you can see the contractor is wetting out some glass on a piece of cardboard, and that piece of cardboard is your tool for bringing that wetted out joint lamination to the joint area. And when you do it in the trench, the underside of the duct, this is where this cardboard really comes into play, because you literally slide this cardboard under the duct and lift the patch area onto the duct. Even in above ground applications, the workstation, all right, that's essential. You need to have all of your glass set up. Um, uh, if you have workable size patches cut and ready to go, everything is there for you. It'll make life much easier. Okay. When you're doing double wall duct, and so far all you've seen is single wall duct, as standard, Minoxidant supplies this fiberglass ring, an alignment ring, and it is slipped. There's no interior sealing here. It's slipped into a groove that we supply on either side of the joint, and then that perfectly aligns the inner duct. And then when that joint is ready to be done, or multiple joints are ready to be done, the outside only is sealed with the wet layup joint. Okay, so that basically didn't answer your question, did it? How do I figure the labor for doing this joining? Well, that question came up at a recent training, and the folks from the factory, their answer was, well, a 24-inch round duct by one mechanic who does this every day can do it in 5 to 6 minutes. That's everything. That's preparing the joint, grinding it. That's cutting their own glass. That's wetting their own glass out, mixing their own resin, all by themselves, 5 to 6 minutes for a 24-inch joint. Now, if you are that experienced, well, there you go. There's your labor cost. Bigger or more conservative way of looking at it is to say, well, if you've got a workstation and then you have somebody in the trench or on the scaffolding, then 10 to 15 minutes for two mechanics each to do a 24-inch lamination, that's probably realistic. Now, that's, again, you have to look at it from the point of view as you're doing 7 or 8 field joints all at the same time. You're not doing one and then moving on to the next. That's basically how you run out of resin. So there's your labor estimate. A 24-inch diameter joint, 10 to 15 minutes for two mechanics each, and there's your labor. And an added benefit to having wet layup joint materials on the site is, well, it's not a perfect world that we live in. Obstructions do happen, conflicts do occur, and there are times, no matter what the material, where, well, you can't get things to line up the way you want them to. Well, with other materials, that's an issue because you have to modify that material to make it fit. And obviously, this is extreme that you're looking at here. If you were to try to seal that with caulking, impossible. Welding would be impossible. It would be a nightmare. You'd have to get pretty creative. Well, with FRP, it really doesn't matter because the wet layup joint, and this is important to understand, the wet layup joint is not a glue. It's not a sealant. It actually is the same process, the same materials used when they actually make the duct. So when all is said and done, that wet layup joint is as strong, if not stronger, than the duct on either side of the joint. So when things don't align, it's not really a concern for FRP because you can bridge that gap with wetted out matting, and there's no issues whatsoever. So that's a distinct advantage. Now, when it comes to the wet layup joint, okay, there are 4 levels of support that we offer here at Minoxidant. And obviously, every project gets written instructions that you saw in the video. We have the video itself. We can do remote webinar presentations like the one we're doing this morning. And then the last one is on-site factory training where, and yes, there's an asterisk next to that. And the reason for that is that we will go to the job site if training is required if the contractor is not sure or hesitant to do this, and we will do this at no charge to the contractor. The catch is that when we're in that town, in that city, we ask that the representative do take us out to your engineers, contractors, and so on, so we can do presentations. That's, I think, a fair deal. But what it does is it helps the contractor to not make mistakes, not that they're complicated, but not make mistakes and end up with a smooth and easy install. Now, no matter how many people you talk to, there's always going to be somebody who's just not comfortable with doing FRP, okay, with doing wet layup joints. So what we are going to show you next is something that is literally brand new. The thermoset SMACNA Thermoset FRP duct construction manual was originally written in 1995, and back in 95 it was all about wastewater treatment plants, water treatment plants, all about how to build and join corrosive ducts. Well, SMACNA has rewritten it. A member of our team here was on the committee to rewrite it, and this go around they are devoting an entire chapter to underground FRP because they realize that more and more FRP duct is going in the ground. And in this manual, they're certainly saying that the wet layup joint, as we just went over, is fine. There's nothing wrong with it. But where water table is not an issue, a dry joining method may be used. So this is literally right out of the SMACNA manual, and they're talking about using a metal sleeve and screws, a screw gun. So this is probably more in line with contractors' mindset that normally screw metal duct together. And it is just that. You have a metal sleeve that is inserted in one side of the duct and it's screwed, and then the other side of the joint is attached. And that is, like I said, more in line with the mindset of sheet metal workers, duct installers. They get to use their screw gun again. So they're screwing both sides of this metal sleeve. Then they are putting a non-hardening UL listed waterproof duct sealant. It's very common with metal duct, same exact stuff. They're using that to do the seam and also the joints. And then once that is done, they are wrapping it in butyl rubber tape. Polyethylene back, they peel it off and wrap it around, and they're done. So this goes back to the discussion where they're connecting one set of duct, and they are finishing it start to finish all in one setting. That to some makes more sense. So when it comes to installations where water table is not an issue, you have the option of using this now SMACNA recommended dry joint or the wet layup joint. That is available to you now. So no matter what joint method you do use, keep in mind, as compared to other materials, your duct is going to come out factory manifold, requiring the least amount of field connections, no matter what you use in the first place. So that means less time to install, less labor to combine, and more efficient projects. So if there are any questions, please feel free to throw them out now or email any of our staff. Their email addresses are all on our website. And with that in mind, I would like to thank everybody for attending. I hope I answered everybody's questions, and this concludes our webinar for this morning.
Thank you, Jim. That concludes today's webinar on underground FRP installation made easy, facts and fiction. Please contact our support team for design assistance, quoting, or any other requests. Please remember our website, fiberglass-duct.com, is home to a complete catalog and various other resources. This webinar and all previous webinars are on the Minoxidant YouTube channel. These presentations are linked off of our website, fiberglass-duct.com. Click the Dig Deeper tab and click Webinars. Minoxidant's next quarterly webinar will be Thursday, January 26th. The topic will focus on Minoxidil's source capture product line. We realize you all have busy schedules, and we genuinely appreciate the time you've spent with us. Thank you and have a great day.